Hi, I'm Patrick, and I'm here recording an expert answer for you in Algebra 2. So here's the question. Given that log base r of pq equals m, the log base p of qr equals k, and it says n6, but the 6 is a typo because when we leave it out, the solution works. So log base q of pr equals n. Show that m plus n plus k equals m times n times k minus 2. To do this, we want to get, these are all in different bases, so we want to use the change of base rule to get them all into the same base. Now you can pick whatever base you like, but base 10 is most common, and you don't write the 10 by convention. And so the change of base rule says we take the log to the new base of this term and put it up here, divided by the log to the same base of the base, which is r. So we have log of pq over log of r. And this is by the change of base rule for logarithms. Now we can use the product rule for logarithms because we have log of p times q. And by the product rule, we can make this log of p plus log of q. So now, m equals log of p plus log of q over log of r. And likewise, we can do the exact same thing for n, change of base rule, and then the product rule for logarithms, and the same thing for k. So we use the change of base rule, and then the product rule for logarithms. So now we can write all those together. If we add all those three together, because we're wanting to find out what m plus n plus k is, we can write the terms like this. So for m, this is the same as log of p over log of r, plus log of q over log of r. So we've written those two terms here. And then for n, we can do the same thing. So that's the same as log of p over log of q, there, plus log of r over log of q, which is here. And finally, for k, we have log of q over log of p, plus log of r over log of p, and that's here. And we can rearrange these terms if we like. We don't have to. I grouped the log of p terms first on the numerator, so here, then the log of q terms, then the log of r terms. And so that takes care of this part of the equation. And so now let's look at the other part, the m times n times k. So if we substitute in our expressions from up here into m times n times k, this is what we get. And we can rearrange these because we can multiply in any order we like. And so now I have log of pq over log of p times log of qr over log of q times log of pr over log of r. And this gives, again using the product rule for logarithms, same thing we did above, we get that. And we can write out the terms individually exactly like we did here. And so we'll do the same thing, and we get log of p over log of p plus log of q over log of p, which is here. And so that's the first term. And we do the same thing for the next two terms, log of q over log of q plus log of r over log of q. And finally, the last term, we get, I flipped it around because I wanted the one to come first, log of r over log of r plus log of p over log of r. It doesn't matter in which order you add them. And we notice that we have log of p over log of p, log of q over log of q, and log of r over log of r. Anything divided by itself is 1. So we can make this look a little simpler by writing it like this. So now we have these three terms to multiply together. And now if we remember how to multiply these kinds of terms together, we can start with the first two. And we use you can use FOIL or whatever works for you. But let's multiply, and we'll go through it. Multiply this times this, we get 1. And it looks like I did it out of order, but I'll do the outside. 1 plus log of r over log of q, or 1 times that, gives this term. And then log of q over log of p times 1 gives this term. And finally, the last term is this times this. And you'll notice that the log of q's cancel out. And we're left with log of r over log of p. And that's here. And we still have this last term, which we haven't multiplied yet. And so now we multiply all of this times each term in this. And so you have 1 times 1 plus log of q over log of p times 1. So that's here. Plus log of r over log of q times 1. That's here. And finally, plus log of r over log of p times 1, which is here. Now we multiply everything, all these four, by the second term. So we multiply this times this. So that's log of p over log of r. We multiply this times this. And you notice the log of p's cancel out. So we are left with log of q over log of r. Then we multiply this times this. And now the log of r's cancel out. So you're left with log of p over log of q. And finally, the last term, you'll notice, all four of those cancel out. It's log of r over log of p times log of p over log of r, and so that's 1. So we end up with a 1 here. And let's rearrange this whole thing. And now we get something that looks very much like what we had above for m plus n plus k, except now there's an added 2 here. If we look carefully, this is m plus n plus k. They are the exact same terms, except m nk has this plus 2 here. So comparing those two, we get the final answer. M plus n plus k does equal m times n times k minus 2. Thank you.